Good day. So in this video, we're going to look at coordinate geometry, specifically focusing on the equation of circles. So without wasting time, let's get into it. Now, one thing that I just want to state at the beginning is that I've had students saying that a circle is a function. A circle is not a function. So remember, if you do a vertical line test, if this is a function, the line has to touch the function once. The moment it touches twice or thrice, then that's not a function. And if you do a vertical line test on the circle, you can see that this is not a function. But however, since it has some points that obeys a general pattern, therefore we can get a general equation for the circle. So with that in mind, one thing that you need to be familiar with is the general equation of the circle. So the general equation of the circle is given by, so if you have got the center AB, so the center has got the coordinates AB and the radius R, then the general equation of the circle can be given by this equation. That is x minus the x coordinate of the center. So that is x minus a squared plus bracket y minus b bracket squared, where b is the y coordinate of the center. So this will be equal to r squared. So just the square of the radius. So this is how you determine the general equation of the circle. So if you're given, for example, you're given, let's say they say that the center it's a 3, 4, then the radius is equal to 5. So you're going to be able to determine the equation of the circle already. So then you just substitute back the a value and the r. So in this case, you get x minus 3 bracket squared, then plus bracket y minus a 4 bracket squared is equal to 5 squared, which is 25. So that will be the equation of the circle. So you just leave it like that. So now let's look at the expanded form of this equation. Now, this equation, x minus a squared plus y minus b squared is equal to r squared, can be expanded to get this equation in this format. So that will be now x squared plus y squared plus gx. In this case, g is just the coefficient of x, then plus fy, where f is just the coefficient of y, then plus a constant c is equal to 0. So when you are working with this expanded form, you want always to put your 0 on this side of the equal sign. You will see why in a moment. Now, let's look at some examples. So this equation can be expanded. You can get an equation 3x squared plus 3y squared, then plus 2x plus a 4y, then plus 1 is equal to 0. Now, this equation is an equation of a circle. So one thing that you need to take note of, the coefficient of x squared and y squared, they should always be the same. If they are not the same, that is not an equation of a circle. It is an ellipse or something else. So for example, if you have got 3x squared plus 2y squared plus 2x plus 4y, then plus a 1, then is equal to 0. So automatically, this is not an equation of a circle. You're not dealing with a circle here because the coefficient of x squared and y squared are not the same. So now, with that in mind, let's look at how you can determine the radius and also the coordinates of the center. Now, for the formulas that I'm going to give you now, you should always make sure that the coefficient of x squared and y squared are equal to, they are 1. So if there is a 3 or a 3 there, then you just need to factor out the 3 from the whole equation. Then you can use the formula. So with that in mind, the x coordinate of the center, can be simply be determined using this formula, minus a half multiplied by g. So it's just minus a half multiplied by the coefficient of x. Then as well, y coordinate of the center. The y coordinate of the center can be determined by minus a half multiplied by f. So in this case, that is minus half times the coefficient of y. Remember, the x squared and y squared, they have to always be 1. So if there's a 2, factor out the 2 first. So then the coordinates of the center will just be given as, so the center will be equal to, in this case, negative half g, which is negative half times the coefficient of x, not x squared, then negative half coefficient of y. So this is the center. Then the radius can be determined using this formula, which is equal to, so remember the center, it's a and b, because that's are the coordinates of x the x coordinate and the y coordinate. So then once you have got the coordinates of the center, you can determine the radius using the coordinates of the center. So in this case, we just square a squared, which is this x coordinate of the center, then plus b squared, which is this y coordinate of the center, then minus your c. Your c is this constant here. So remember, it is always to be that side. So that is how you determine the center and the radius if you are given this expanded form. However, if it is in this form, that is easy. You just read out the center is AB, and also the radius, you just square that r squared. So with that in mind, let's look at some examples. Now, in this question, we are asked to determine the equation of a circle. Question 1, this one, the first one says, find the equation of the circle with center 8, 2 and radius 5. So that is quite easy. We have got our center and we have got our radius. So remember, the general equation of the circle is x minus a, which is the coordinate of the x coordinate of the center, then plus bracket y minus b, which is the y coordinate of the center, is equal to r squared. Then you just substitute here. That will be x minus 8 bracket squared, then plus bracket y minus 2 bracket squared is equal to 5 squared, which is in this case 25. So that will simplify further to be x minus 8 squared. There's no need for you to expand this equation. You just leave it in this format. You'll be awarded 4 marks. So that will be equal to 25. And that is how you determine the equation of the circle. Now, in the next question, we are asked to find the equation of the circle with the center. So we have the center again, passing through the point 86. So it is passing through the point 86. So the circle passes through that point. So we don't have the radius. But once we have got the point that is on the circumference, we can determine the radius using the distance formula. So r in this case will be equal to the square root of, let's say, remember the distance formula. Let's write the formula first. It's x2 minus x1 bracket squared plus bracket y2 minus y1 bracket squared. So in this case, that will be equal to the square root of, that will be 8 minus a 5 squared, then plus bracket 6 minus a 2 squared, and that will be equal to the square root of, here it will be 3 squared, that will be 9, then plus 4 squared is 16, which is equal to the square root of 25, which in this case is a 5. Now, we have the radius r, which is 5. And also we have got the center 5, 2. Then we can write down the equation of the circle in this case. That will be x minus a, which is 5, the x coordinate of the center squared, plus bracket y minus the y coordinate of the center, which is 2 squared, is equal to 5 squared, which is 25. And that is how you determine the equation of this circle. Moving on to the next examples. Now, in these examples, now we are given the equations of the circles. We are asked now to determine the radius. So this is a vice versa of what we've been doing on the previous section. So we are asked to determine the radius of the circle and also the center. So for this one, it is already in the format x minus a bracket squared plus bracket y minus b bracket squared is equal to r squared. So then we just read out the value. So then the center will be a 3 and positive 8. And also the radius, that will be the center here. So then the radius will just be equal to the square root of 25. And in this case, that will be a 5. Because remember, this is always r squared. So that is a 5. Now, in the next question, we are given that expanded format. So remember, we have to check the coefficient of x squared and y squared. In this case, they are all 1. So that's fine. So we can go ahead. So then the center, the coordinates of center will be equal to, remember, negative half multiplied by the coefficient of x, which is in this case negative 6. Then here negative half multiplied by the 4. Then that will be equal to, that will be a 3 right there. And then that will be a negative 4. Now that those are the coordinates of the center. Once we have coordinates of the center, remember we can determine our radius using the formula. Radius is equal to the square root of a squared plus b squared minus a c. Remember, your c always has to be this side. So that will be equal to a squared, it's 3 squared, that will be a 9, plus negative 4 squared, that will be 16, then minus a 3. So that will give us here the square root of, so that is a 9 plus 16, 25, minus 3, that is 22. So that will be the square root of 22. So that will be the radius. So yeah, can you please try this number 3? Then you let me know what the answer you get. So if you get it right, so that will be nice. Now let's move on to the next section, which is the intersection of a line and a curve, or a line and a circle. Now, this is also another interesting property of the circles. So this want to determine now the points of intersection of a secant. Remember, a secant, it is a line that is drawn through this circle, like this one here, the green line. This is a secant because it touches the circle 2 times. If it is drawn outside like this one, remember this is a tangent. So now if you want to determine the points of intersection of these two, which is the secant and the circle, you can just equate the two equations together because it's a point of intersection. So you just make, if this is a G and F, so you just say G is equal to F. But in other instances, they won't give you maybe the gradient of G. They can give you a K value in the equation, and they say, please determine the values of K, which satisfies these two equations. So to do that, you can see that these two meet at 2 distinct points. So if they meet at 2 distinct points, you have to remember now when you solve this, that will be the discriminant b squared minus 4ac should be greater than or equal to 0 because they are meeting at 2 distinct points. You will see in an example in a moment. However, for the tangent, they meet at only 1 point. So which means there is only one distinct value for the value of x and y. So that will be now the discriminant will be b squared minus 4ac should be equal to 0. Yeah, with that in mind, let's look at some examples. Now, in this example, we are asked to find the value of k for which the line, so that is a tangent. So this is a line, a tangent, you can see it's like in the format y is equal to mx plus c, where m is 2k. So is a tangent to the curve y is equal to 3 plus kx squared. You can see this is a quadratic equation. Now, since it's a tangent, so it meets 1. So remember now, b squared minus 4ac in this case will be equal to 0. So then we can equate the two equations together to find that point of intersection. So in this case, we say 3 plus kx squared must be equal to 2kx plus 7. Then we can say here kx squared minus 2kx. Then we can bring the 7 this side. That would be negative 4 is equal to 0. Now, we can now determine the discriminant and let it equal to 0. So then the discriminant is b squared. So that will be negative 2 squared. That will be 4k squared minus 4 times a, it's a k, times that will be negative 4 is equal to 0. So here that can be simplified further to be 4k squared, then minus 6 plus, actually negative times a negative, that is 16k is equal to 0. Then we factor out 4k, then bracket, then we are left with k, then plus a 4 is equal to 0. So k will be equal to 0, or k is equal to negative 4. So there are two possible values for k, because the tangent can be either passing through the 0 line or 0 point, or can also be passing through another point. So there can be two possible values on a quadratic. Yeah, I hope that makes sense. Now let's move on to the next example. Now, in this example, we are given a circle, the yellow one, and also a tangent AB. So the equation of the circle is x squared plus y squared plus 6x minus 8y is equal to 0. So yeah, once you're given the equation, the first thing that you want to determine is already the coordinates of the center, even if you're not asked. So then remember, we say the coordinates of the center, we check our equation. So our equation, it has got the coefficient of x squared as 1, and also the coefficient of y squared as 1. So therefore, the center will be equal to a negative half multiplied by the x coordinate, the coefficient of x here, and that will be 6, then negative half again, multiplied by the coefficient of y. That will be negative 8. So in bracket, then that will give us here a negative 3 and a positive 4. So these are the coordinates of the center, which is negative 3 and positive 4. So once we have got the center, we can also determine the radius, by the way. But anyway, on the first question, we ask, find the length of OA, and that is the radius. So remember the radius, once you have got the center, you can say radius is equal to the square root of a squared plus b squared minus c, where a and b are the coordinates of the center. So that will be equal to the square root of negative 3 squared, that will be 9, plus 16 squared, that will be, plus 4 squared, sorry, that will be 16. Then your C here, there is no constant, it's a 0. So then the R is equal to 5. So the radius is 5. Now, in the next question, we are asked to find the length of AB. So to find AB, we need the coordinates of A and B, then we can do distance formula. But since we do not have that, but we have got our radius is 5, and you know that at the point of intersection of a tangent and the radius, there is a 90 degrees. So a 90 degrees form, remember your circle geometry. Now, so what we can determine OB. We can determine OB using the distance formula. So once we have OB, we can do Pythagoras theorem with that. So OB, you can say 4 minus 4. That will be 16. That will be 4 minus 4, it's 8. So that will be 64. 8 squared is 64. Then minus 3, that will be minus a 9. Minus a 9. So that, no, it's a plus, because that is minus 3, that will be a 9. So it's a plus. So then that will be the square root here of, that will be 673. Square root of 73. Right, so now we have got the length of OB. Now we can do Pythagoras to get AB. So we can say here, OB squared is equal to AB squared plus OA squared. In this case, that will be equal to OB squared. We know our OB squared, that will be just 73, is equal to AB squared. That is the one that we want. AB squared is what we want. Then plus 25. Then we just bring that 73 minus 25 is equal to AB squared. Then we can say the square root of 73 minus 25 will be equal to AB squared, AB. So that will be now, so yeah, that will give us square root of 48. So the answer will be square root of 48. Now let's look at the next example. Now, in this final example, which is a typical exam question again, the points P, Q, R have coordinates 2, 1, 6, 2, and 2, 18 respectively. So one thing that I want to do here is to draw that those coordinates. So it forms a triangle. So we have got here P, Q, and your R. Then P will be the coordinates 2, 1. Then Q will be the coordinates 6, 2. Then R will be the coordinates here 2 and 18. Now, so part 1, we are asked to show that PQR is a right angled triangle. So there are two ways we can do this. We can use Pythagoras, or we can do the gradient of the lines, all of them. Then we can find which one they multiply each other. If they give us a -1, then they are perpendicular. But now in this case, I would like to use the Pythagoras. So we can be able to find the length of QP using the distance formula. Remember the distance formula. So in this case, that will be 6 minus 2 squared. That will be 16 for its 4 squared. Then plus 2 minus 1 squared. That will be 1. Then we can also determine this side. That will be 2 minus 2, then squared, it's a 0. Then 1 minus 18, negative 17 squared. That will be just negative 17. Then for this side here, we can say 6 minus 2, that will be a 4. Then 4 squared, we know that is a 16. Then plus, then yes, 18 minus 2, that will be a 16 squared. Okay, now we have got all the sides, and we can see this here will be equal to the square root of 272. And here that's just equal to 17. Because square root of 17 squared is just 17. And here that's square root of 17. So we can see that the bigger side here is PR. So if this is a right angle triangle, then PR should be the hypotenuse. So then we can say now PQ squared plus QR squared should be equal to PR squared. In this case, our PQ, it's square root of 17. So square root of 17, then squared, plus QR squared, that is square root of 272, then squared must be equal to whatever PR squared will be. So let's just put PR squared. We know that PR squared will be 17. Yeah, that will be 17 squared here. Now, 17 squared, that will be just, square root of 17 squared, it's 17, then plus 272 is equal to PR squared. Then we can say this is, when you add that, that will give you 289 is equal to PR squared. And then we can simply find the square root of 289, and we can say PR is equal to 17. And you can see that is 17. Therefore, we have got a right-angled triangle. Now, the last question says that hence find the equation of the circle that passes through PQR. So if we have here our right angle, so automatically this becomes the diameter. Remember, if we draw a circle, an angle in a semicircle, it's a 90 degrees. So that would be 90 degrees. So we need to find the midpoint of this line PR. So we need the midpoint of PR. Then if we get the midpoint, then we can divide this 17 by 2. We've got the radius. Then now you can determine the equation of the circle. Yeah, this marks the end of this lesson, and let me know what you think. I'll see you again in the next video. So bye for now.